Let's see why FeenoX works this way. Let's go to the directory where the tutorials are, the tensile test case. Let us solve this case, which is the first tutorial. The geometry is this one, so it reads a step file, defines physical volume, surfaces for boundary conditions, and mesh settings. So we can then mesh this thing with Gmesh, and we get a pretty coarse mesh, right? Then we solve this problem with FeenoX. Which problem? Okay, the one defined in this input file. These are the lines that define the problems. These are the lines that write the output as explained in the tutorial. So we run this through FeenoX and we quickly have an answer, and that answer includes this VTK file, which has the stresses, displacement, whatever. But the important thing here is that we have a coarse mesh. Now, what happens if we wanted to solve a very big problem that doesn't fit into our computer, which might be a low-end laptop? Well, let's assume that we have a cloud server which we can log into. Let's create a temporary directory here. So this is a very big cloud server. Now let's copy the files that we need. We need to copy tensile test.geo into that directory. Right, we have the geo. We have to copy the input file for FeenoX, and finally we also need to copy the step file as well. Now let's switch into the supercomputer. We have those input files. Then we can edit the geo file with Vim and change, for instance, the mesh size. Let's make it smaller. Let's change the optimization. Then we can run Gmesh on the cloud server to have a finer mesh. In principle, this can be, I don't know, millions of nodes or have a massive parallel supercomputer. We're not going into detail, we're just illustrating how this works. So now we have a mesh file. Then we can run FeenoX and we will ask for progress so we know where we are. Dots indicate that the stiffness matrix is being built. Now dashes will indicate the progress of the iterative solver solving the system of equations. It's a bigger problem, so it takes some time. Now we are solving. Now we're computing the stresses, writing the output, and now we have this VTK file, which is pretty big. It's 23 megs. We can compress it, and then we're going to download it. Copying it back. So from the server, it's called tensile test.vtk.gc. We can copy it back to our computer. And then we have it there. We can extract it, overrode the older tensile test.vtk, which had the coarse mesh, and now we can see that we have a finer mesh in our computer. So we solved the problem in the cloud, and then we watch and see the results in our computer. And that's how FeenoX works the way it does.